So, let's talk about the problem that I want to do today. My goal is to do 2 of these, and I'm going to start with something kind of easier, and then tomorrow we'll kind of delve into the more difficult problems. Here's the idea. Here's what we're doing. We're in section 1.3, and the section that we're in, it is graphing polynomials, but there's a major piece of this. I know that the last couple sections we've been graphing polynomials. I understand this. It's been graphing functions, graphing polynomials, whatnot. The goal in this section is to find what they call a minimum value, or a maximum value on a graph. A max or a min. It is the highest point on a graph or the lowest point on a graph. After you draw it yourself. And you have to find out where it is. So just think about this. So you don't need to draw this first example, but we've been doing problems where we've been doing problems like this, right? Stuff that looks like that, okay? Drawing it, see if it bounces off the x-axis, if it passes through the x-axis, where it hits the y-axis, all that good stuff. Where I've been drawing all these little things and trying to piece it together how many times it should change directions. What we're doing today is figuring out these. Where it has hills and valleys. Okay, the peaks and minimums, peaks and valleys. So that's kind of the idea. We're going to start with something easy. We're not going to do a problem like that where there's like multiple items. We're going to do one that just has one today. And so you get the chance to just, can we find the one peak or one valley on a problem? And would it make sense? Can you find it? Do you know the rules for what we have to do? Okay? So there's a couple vocab terms I want to talk about today. Today is kind of an intro day. So don't think of it as, you need to be an expert at this when you walk out of here. I just want you to get a sense for how to do it. And then tomorrow we'll polish it and make it look better. Okay? But the good news is that we're not leaving the section we were just in, right? We still have to do the little things that we did in the last section. Find x-intercepts, find y-intercepts, figure out where the tails go, figure out how many times it would change directions. We are still doing that stuff. It's not going away. But now we just add an extra piece. So it's giving us a little more information. Now, some of the vocab terms that we need to talk about. We need to talk about an absolute versus relative max and mins. So this is a term that we're going to get used to, okay? And hopefully it'll make sense. Instead of relative max and mins, sometimes your textbooks call them local. That's what my calc textbook calls them, local max and mins, instead of relatives. Okay, it is finding the points where the graph actually changed directions, and an inflection point. They're actually called critical points. That's the correct term according to Calc 1 and Calc 2. So this is the idea of what we're going to be finding. Now, obviously, we're not going to. That word is something you get in Calc 1, but we're in pre-calc, so it's kind of nice to know what we're finding, know some of the vocab terms. Okay, so does everyone understand the basics of what we're going to be looking for today? Peaks and valleys. Okay, I'm going to start with an easy one. We'll try one more after that, and then I'm going to call it a day and let you work on your worksheet, because I know we have homework due tomorrow, correct? For that worksheet. Did anyone not receive that worksheet yesterday? You came in. Okay, so I know some people are back for the first time. Welcome back. Or you're gone. We'll get you kind of straightened out. Don't feel like it's the end of end of everything. We'll get you balanced back out. We'll try to do our best to kind of fill in on the rules, whatnot. So this will be due next week for you guys since you just got it. I think we had this worksheet. What? Did we just get this yesterday or was this Tuesday? Tuesday. It's been a while. So. For those who just got back, I figured you were coming back, so I was just going to give you a physical copy. I didn't send it out by email. Sorry. So, all right. Are we ready to go? Does everyone have everything ready? Notes, everything? Okay, let's jump right in. Let's start with kind of a starter problem. That's what I like to call it. And then we can really talk about what we're going to do. Okay, for the first problem here, here's the first one. X squared plus 5x plus 6. Let's go with a minus here. can't see it, let me know. I know it's, you can get a weird glare on that side of the room, so we can see that. That neat. All right. Okay, let's walk through the basic rules what we did last time. So we're still going to polish what we did, the last couple days in here, graphing. It'll help those who are just showing it for the first time for a while. Maybe they can see in person, understand what we're talking about. What are the rules we talk about for the 7-step method? Somebody walk me through. What's the first rule we do? Please.
And behaviors.
And behaviors. Where the tails go. The outside tails. Not the middle stuff. The outside tails on my graph. This one, what do you think?
So our highest degree is 2.
Okay. That is a critical thing we have to look at. So what does that tell me?
It's even, so the tails are going the same direction?
Same direction. So on mine, for the end behavior, the tails go the same direction. So they're either going both up or they're both going down on my graph. The outside tails. I don't know about the middle stuff, but the outside tails, the final, like the farthest left, the farthest right tail. Do you happen to know where these are going, up or down?
You have to look at the leading coefficient.
Yep.
Which is 1, and it's positive, so it would be going up.
Yep. It's a positive number, so we're going towards positive numbers. So we're going up. Up are positives on my y-axis. It's kind of the easiest way I can explain it. So you're absolutely right. My outside tails are going up. Now, again, I will move the tails here in a little bit. This is just a rough idea where they're going. Does that make sense for rule number 1? Thank you for that. Okay, somebody else now. What's our second rule that we need to do? Second rule. Please.
Find x.
Yes. X-intercepts. So that's the next thing. How do we find x-intercepts?
You have to factor it.
Have to factor it. Or quadratic formula if you don't know how to factor. We haven't done quadratic formula yet. That's coming up in later sections. Trust me, it's still coming. I do review it at some point, but not today. So that's not going to be a part of our test here. All right, x-intercepts. How do we factor this little guy? What's the rule? Trinomial rule, yeah. It's going to be a trinomial. There's no common factors between all of them. So trinomial, we're going to have 2 parentheses. The sign in the back tells me it's going to be plus minus. The minus sign in the back tells me they have to be the opposite signs. If this is a plus, they have to be the same. And we'll have to figure out what they are. But they're both opposites. Break up the x squared. And how do we break up 6?
6 and 1.
6 and 1 or 3 and 2. It's got to be 6 and 1 because we need to make the 5 in the middle. And I know you're thinking, well, 3 and 2 make 5. Yeah, but we're subtracting the numbers. Positive 6, negative 1. Those will add or subtract together to make the 5. If they're both pluses, yeah, 3 and 2 would be the right idea. Now that we have our factoring, now that you can see the factoring of this problem, what are the x-intercepts that represent each of these parentheses?
Negative 6 and 1.
Yeah, negative 6 and positive 1. It's always the opposite of numbers on the inside. If you don't know that, just set them equal to 0 and solve it. Right? That's a quick way to do it. So these are my 2 x-intercepts. Now, are we going to bounce off of them or pass through them?
Pass through.
We're going to pass through. Now, here's how we know we're going to pass through each of these. We're going to pass through each of these x-intercepts on my graph. Because your degree on each of these parentheses was a 1. I didn't have a parenthesis that repeated more than once. So we're going to pass through these x-intercepts. So negative 6, 1, 2, 3, 4, 5, 6, and positive 1. Okay. So far so good? Okay. Y-intercept.
Negative 6.
Negative 6. So for the y-int, this is where you just take your problem, whatever your original problem is, and put in a bunch of zeros for all the x's. All the x's. Wherever there's an x, put a 0 there. And so it tells me my answer should be negative 6. So that's what, here? 1, 2, 3, 4, 5, 6. All right, and now I get a sense where this thing is graphing. Is it symmetrical? No. It's a mixed bag of even and odd powers. If you even look at the graph, I can already tell you it's not symmetrical by just the x-intercepts tell me that. And it's going to change directions 1 time as it goes because your highest degree and you subtract 1 off of it. So this thing will change directions once. So this is the overall view of what we're looking at. pass through each of these x-intercepts. We're coming up back through, and the tails are going to finish going up. And so it makes sense with all the numbers and all the data that I'm given. This makes sense for my numbers. Now, our goal today, our goal here for this next piece we're going to add, is to figure out where that little thing is. That little guy. That critical point, that low point. It is an absolute minimum on this graph. The reason why, there is no point that will go lower than that. So that's why they call it an absolute minimum. Absolute min. An absolute minimum to this graph. It's the lowest point. That's what absolute means. It could be an absolute maximum. Maybe your graph goes down, so it's the highest point. If you had a bunch of times where it goes up and down, we're going to have to find all those peaks and valleys. Those are called relatives, right? Where you have more than one, right? You have relatives. But an absolute is like the highest or lowest point. Okay, there's no point that will go lower. If there's an arrow that points down, we don't have an absolute. It's got to be the lowest point no matter what. No arrows can beat it. Okay, does that make sense what we're doing today? I like to do that little review with you. It's just nice to see that. Some of you are new to this stuff. So it's probably one of the first times you're seeing it in person. There's a lot you have to put together. So remember, it's got to be the end behavior where the tails go. X-intercepts, Y-intercepts. It's got to be, is it symmetrical or not? Does it look clean across the Y-axis? And then, how many times does it change directions? But now we add where's the lowest or highest point. Okay, are we ready though? Ready for the new stuff? Okay. All right, this is kind of a massive undertaking. All right, so you need to have some room in your notes for this thing. The goal is to figure out that little absolute minimum. And again, remember, this is the intro day to it, so don't panic. All right, so what we're going to find is the absolute minimum on this particular graph, because I already get a sense where it's going. To do that, this is the item that we're going to do. It's called a differential quotient. It's called a differential quotient. It is a formula that you do that will help you identify where the lowest point will be. It takes a little bit of effort. So I've kind of pre-warned you earlier this week that this process will take a long time to figure out. So don't feel like it's a quick hitter where you can type up the calculator and hit enter and it just spits out your number. It doesn't work that way. I will show you a shortcut for this particular graph that will help you with it. But this is the real way you're supposed to do it for any type of polynomial. So I think it's important that we see how to do it on any type, not just this specific example. So here's the formula you need to have written down somewhere. I know this is going to seem really weird, but do your best to write this down. F of x plus h minus f of x, and then you're going to divide everything by h. This is your formula for the differential quotient. All right, now, I want to explain to you in the most common sense way I can of what is this formula and who came up with it. Okay? This formula, I am not joking you, is the slope of your line. That thing. Now, is that an actual line? No, it's curved. Curves. That blue marker is terrible. I can hardly see it from where I was sitting. That looks a little bit better. All right. So this thing is a curve. So the slope is changing at any moment. No matter where you're at on the graph, the slope changes. What we're looking for on this thing is we're looking for when does the slope hit 0? Because this would be, if I were to I'm going to use this marker as like a slope, right? A line. So imagine this is a line. What type of slope is this for this type of line? Is it positive, negative? What is it? That's negative slope, right? So over here, all these numbers are negative numbers for slope. No matter where, if you picked a point, it would have a negative slope. right? And eventually, when you get to this low valley, the slope would be straight across. The line would be a horizontal line. That is called zero slope. That is what we're looking for. So keep that in mind. We're looking for zero slope. And then on this side, all the slopes would be positive numbers. You know, it'd actually be getting bigger and bigger and bigger. The slope would be going up. So we're looking for the absolute minimum when slope would be 0, when it hits a peak or valley. That's what we're going to do for this thing. So that's kind of the overall idea. Now you're thinking, this doesn't look anything like slope. It does. Okay, so this is the part you don't need to write down. I just want you to see this for the first time. This is what this problem is actually based on. Okay, do you recognize this?
A little bit.
That's your slope formula, right? That's what they teach you in Algebra 1. You subtract y's, y1 minus y2 over x1 minus x2 or whatever they call it. It's n, right? Rise over run. That thing you're looking at there in that little box is this thing. It is this. It just looks different. Instead of writing y's, they write f of x's. F of x means y, right? It's whatever x you're plugging in, that's your y's. It's just a big fancy way of saying it. It's the name of the function plus whatever the variable you plugged in. Well, the variable they plugged in wasn't just x, it was an x plus h. That was the thing they plugged in here, x plus h. And so when they plugged in an x plus h in the front here, they had to use that same term here. The same exact variable, x plus h. Because that was the letter that they chose to put in the front, right? That was the first y1. Well, down here, what happens if I were to get rid of this parenthesis? How would you actually subtract that? What would happen on the bottom? X would cancel, and you're left with that. That's what it is. It's slope. So don't think it's some almighty fancy thing. It's not. It's slope written out in very generic terms. Now, what we're going to do is some serious Algebra 1 and Algebra 2. Now I'm talking, we're doing some serious math here in about a 2-second period. Okay? But I want you to know that this is the formula we're going to use. So I'm going to come back to this. There is 3 pieces. There's the upper left corner, this thing. There's the upper right corner, and then there's the bottom. That's what I'm using. I'll probably need most of the board here. So, in fact, I'm going to erase all this, and I'm going to come back to this graph here in a second. So I can use most of this board to help me out. All right, we ready to go here? Okay, so here's what we need to do first. I'm going to take my function, this thing. This is my f of x. I'm going to plug it into this mess. What I mean by taking that and plugging in here, what I'm doing is I'm taking my function and using this as my variable, and I'm plugging into all the x's. So this upper left corner, this spot right here, which is this thing, is your formula, your function, with x plus h's plugged in. So here's what it's going to look like. It's going to look like x plus h squared plus 5 times x plus h, and then the minus 6. You see how it is your formula that you had. It's your function that we just drew a few seconds ago, but it has all the x's plus h's plugged in where there's an x. You're like substituting, right? You see that? No matter what your function is, it could be the craziest formula in the world. You plug in x plus h's into all the x's that you see, and you write it down, whatever it is. Okay, does that make sense for that upper left corner?
Mm-hmm.
The upper right corner. Now I'm going to put a little minus sign. I'll put it in green so you can really see this. So this minus sign is going to represent this little guy right here. So I have a minus sign. Okay, now I'm going to keep going. Sorry, I'm running out of board space, but I'll just keep going all the right like this. No, that looks terrible. So now that was the minus sign I just drew there. So I just did the first box. Now I have the minus sign. Now the second item, the f of x, this is the original function you started with. What was my function? That thing. So it's the original item you started with, and I'm going to put it in parentheses. X squared plus 5x minus 6. There's the upper right corner. It's your function with nothing else changed. You have to put it in parentheses though. Questions with the start. Does everyone see where I'm coming up with my problem? Upper left corner is all the x plus h's plugged in. It's this thing with x plus h's. then you have the minus sign in the middle, then you just have the original function you started with in the end. And what goes on the bottom? H. H will go on the bottom. Okay, questions so far? All right, now that we're here, now starts the process of doing some serious Algebra 1, Algebra 2 stuff. Okay, so we're gonna have to like FOIL things together and distribute and simplify and all that good stuff. Okay, so each piece I'm gonna be doing here is doing some Algebra 1, and I'm just working with the top as I go left to right. So in this upper left corner, how do we view this little piece? What do I have to do with that? What does this thing actually mean? Yeah, it's this, right? This is that upper corner here. There's two x plus h's, and they're being multiplied together. So in this corner right here, just little piece. So I'm gonna put a little equal sign here. I have the h on the bottom still. Okay, so this little corner, I need to FOIL this out. So I need you guys to help me out with what is this when I actually multiply it out. That's this thing, right? This whole thing squared. So what is that if I were to FOIL? First, outer, and last. What do I get?
X squared.
X squared?
Plus h, or x.
XH, yeah. So because you went x times x times h. Keep going.
Plus hx.
Yep.
Plus h squared.
Good. That's FOILing out first, outer, inner, last. And it didn't matter which order you put it, x and h, didn't matter. You can switch them. Okay, does that make sense how I FOILed it? It usually always turns out to be something like that, just telling you. So after you do a lot of these, you probably can like skip that step. You can just write that down like automatically. Okay, does everyone understand that little piece we just did there? Let's keep going. I'm gonna try to color code so you can kind of keep this in mind. Okay, how do I do this piece right here? What do I have to do with that 5? Distribute it. So this is gonna be a 5x plus 5h, right? Because I have to distribute the 5 at both pieces. And then I have the minus 6, that didn't really change. The minus 6 didn't really go anywhere, right? So hopefully you're paying attention when I'm done there. Got up to this point. Now, what about that back piece, back here? What do I have to do with this?
Factor.
Not factor.
Distribute the negative.
Distribute the negative. I have to take this negative sign, it is actually attached to this parenthesis, and distribute it to every one of these items in here, however many items there are. So this is actually going to turn out to be a negative x squared, a negative 5x, and a positive 6. Question?
So would it almost be like distributing
Yes.
1 number?
Exactly. It's like a -1 and you're distributing a -1. You're absolutely right. Yep. Yep. You're absolutely right. Okay. Now I'm going to stop there just for a second. I want you to catch your breath. Sorry, I get kind of going and I forget that you guys are learning this for the first time. Is there a question or concern, something you missed, you didn't quite understand right now? Maybe you're lost completely. I don't know. Very good. Okay. Now, here's what should happen. This is how you know, because I always like to have a safety check. Because obviously you're doing some serious math, because whatever this function is, this could be a nasty function. You're doing all of this crazy stuff in a row. There could be a lot of items written across the board. And now here's the safety to know if you're doing it right. Anything on the top that doesn't have an h on it, that doesn't have an h, like this x squared and that 5x and that 6, if they don't have h's, what you'll notice is that they're all going to cancel if you did it right. So watch this. So look at this, x squared. Is there a negative x squared down the road? It will cancel. So I'm gonna put a line through this. This x squared and that negative x squared cancels. That should happen every time you do this correctly. The 5x, is there a negative 5x down the road? Yes, there was. Those cancel out because you're combining like terms that make zeros. The 6, is there another 6 down the road? Yes, there is. Those cancel. And all you're left with are items that have X's and H's and numbers with H's, things that have H on them, okay? That's what you're left with. That's how you know you're doing it right. That's like your safety check. Did things cancel out? Do I have just H's left? Okay, so we do. So now what I'm gonna do is I'm gonna write down what we're left with, right? Here's what we finally got down to. So I'm gonna put it over here just so we can keep continuing. All right, we're to the point where I have just the H's on the top. So I have an HX plus HX plus H squared plus 5H, right? That's all the stuff left on the top. If you'd like to combine terms, you can do that. I know I have a couple HX's. I can combine them, make two of them. That's fine. So you can add like terms if you want. You don't have to. Okay, are we good up to this point? That's how you know you did it right. Everything has H's left. We're good. Okay, there's no weird random other numbers. I should get caught that up. I'm gonna write that down, get caught up here. I'll only get to one of these today, just to make sure you know how to do it. All right. So, now what we have to do next, divide everything by H. Every item. This is called the law of division. It's a rule of division. Since there's one item on the bottom, you can divide every item by H. Every single item. Not just one, every item. So what happens if I divide everything by H's? What am I left with?
X plus X plus H plus 5.
Good. Boom. Does everyone see that? Divide everything by H. So H cancels on every single item. It's a rule of division. It's actually a rule of addition of fractions that I can do that. Okay. We got down to the final part. This is the thing we were going for. I needed to get to this item right here. Now we can start to figure out where is the low point on this graph, or the highest point on this graph. I need to get to this reduced function. This function that you're seeing there in that box represents my slope. And this is the hardest part for most people to understand, the extra step you have to do to solve. You have to do this every time at the very end. What we're gonna do is I told you what type of slope we're looking for. On this graph, what type of slope was this?
0.
Zero slope. So we're gonna use that fact of 0. Here's what you're going to do right now in this part. I'm going to plug in H is equal to 0. I want H to be 0. And I also, whatever's left, after I take all the H's, so if there's any H's left, they turn into 0, so things will start canceling if there's a bunch of items here. And then the next thing I want to do is set whatever's left equal to 0. So if I plug the 0 in here, what would be left out of this thing? There'd be what, 2x's plus the 5, right? After I plug that H is 0 in, I need to set whatever's left equal to 0 as well. Because this thing is representing 0 slope, and H was also 0. And I'm going to solve that out. So I'm going to solve this equation for x. It should be solvable. We should be able to solve it. Now, it could be factorable. Maybe this item is a trinomial in the end, and I can factor it apart. This is not. I can solve that. So how do I solve 2x plus 5 is equal to 0? Okay, solve it.
Subtract 5.
Subtract the 5 across.
Divide by 2.
Divide by 2. So my x turns out to be negative 5 divided by 2, which is, what, negative 2.5? 2.5? Negative 2.5. Guess what this represents?
Minimum.
It's the minimum x value. It's the lowest point on your graph. The x number will be at negative 2.5 over, right here. This is negative 2.5 on the x-axis. The lowest point is directly below that. If there is more, so let's say this thing was factorable, let's say it was a trinomial, then there might be more than one low point, because maybe this thing went up and down a couple times. By factoring, it would tell you where all of them are, which is really cool, and you start to see that it works. Okay, so I know the lowest point will be below negative 2.5. How do you think we find it?
Gotta find the y.
We have to find the y number. And this is where you use a calculator. And all you have to do is use a calculator, type it in, and it will spit out the lowest point. So how you do it is you go up here. Now that we know what my minimum x is going to be, you're going to plug that in, and you're going to solve for y. So negative 2.5, we're going to square it. We're going to add it to 5 times negative 2.5, and then we're going to subtract 6. You're plugging in x, and it will spit out your y answer, and the y answer will be the lowest point on your graph. It's awesome how it works. It works every time. So when you find your lowest point, you have to go back to the original problem and plug it back in. So negative 2.5 times negative 2.5, that's 6.25, or something like that. On a calculator, correct? 2.5 times 2.5, 6.25? Yes, okay. 5 times 2.5, that should be a negative 1 point, or that should be 12.5 maybe? Something like that? 5 times negative 2.5? Let me double check my math. Yeah, okay. And then we have the minus 6. I'm gonna add and subtract straight across. This ends up if I added, or take 6.25, subtract 12.5, and then subtract 6, I should end up with 12.25 in the very end. Is that right? Is that what my graph, is that what the number said in your calculator? A lot of you probably just typed it all in, hit enter, and it spit out negative 12.5. So that means my graph wasn't even low enough. The point where this thing dipped, it hit all the way down here. It hit this spot and then it turned around. Okay, we're gonna stop there today. Sorry, I want to do 2 of these, but it's one of those things like this is a massive undertaking. It's not for the faint of heart. This is really some serious pre-calc material you're doing now. We're doing some pretty heavy math. Tomorrow, we'll try another one of these out. And then we'll go to something a little more difficult where there's maybe more than one peak or valley. And I'll try to make up a problem that has more than one. All right. Questions? All right. Now, there's going to be a shortcut for this that I'll show you tomorrow. This is the real math. This is the math we have to do on almost every problem. Unless you know it's a certain type of problem, then there's a shortcut, which is nice to know. Okay, and I'll show you the shortcut tomorrow. It might enrage you a little bit, but hopefully it doesn't. So. All right, questions? Okay, that's it for today. Sorry, it was a pretty heavy day for math. Tomorrow we have a worksheet 2. For those who just received it, it's due next week, so don't worry about it. We'll get you caught up. It's not the end of the world. Just calm your jets a little bit, and we'll get you caught up. So for anyone else that has questions, whatnot, don't be afraid. I had some people come in yesterday, after school. Don't be afraid to ever stop in, send me an email, Zoom me at some point during the night. That's fine. So I just want to make sure everyone's got a chance to look some problems over. So. Okay, hopefully worksheets due tomorrow for all the others, so make sure you're working on it. That's it for today.
Was your tape?
Do I have tape?